Okay?
That'd be like.
So in your discovery activity, for the first part, you did Cartesian coordinates, okay? We travel horizontally and then vertically, kind of like you would on a grid system, like on a street, okay? And then I described to you what polar coordinates were, okay? They have nothing to do with polar bears or anything, but I'm going to move this off to the side here. Okay, we'll come back to that. So in your activity, you plotted the points 2, 2. Okay. Now, if we were to think about rotating and then walking that distance, okay, Callie, how much would we have to rotate?
45 degrees.
45 degrees, okay? So if we imagine this, we know that this was 45 degrees, okay? And then what would the length of that be, Maverick? 2 radical 2, okay? Okay, so in your polar coordinate, you would write 2 radical 2, 45 degrees. Now, without trigonometry, we probably could tell, well, with trigonometry, but you didn't have to think too hard about the 2 radical 2, right? It was pretty easy to see that we had a 45, 45 right triangle there, and you guys knew those relationships, okay? Of the 2 coordinates, that one was popping up quicker to you as I was walking around. Now, the second coordinate, well, was -3, +4. Is that correct? Okay. There's the coordinate -3, 4. Now, if we were going to rotate to figure out what this angle was, okay. Caleb, how do we have to do that?
Tangent of -4/3 and then subtract that from like 180.
Okay, so you did the inverse tangent of -4/3. Talk to me about why you did that.
So you make it like a triangle. That's what the sides are.
Okay, so because you went 3 and then 4. So we have opposite over hypotenuse, inverse tangent of 4/3. Okay, and then since it's in the second quadrant, you talked about subtracting it from 180. So what was that angle?
I don't know. I just know what it ends up being.
Okay,
What
does
was
somebody
it?
have that?
Where's the guy? When you put in the calculator.
One what?
126.87.
Oh, I thought you.
Okay. And then how far would we have to walk to get to that point? Keegan? 5. Okay. Here we have a 3, 4, 5 right triangle. So if we rotate 126.87 degrees and then walk 5, we get to the same place. Okay. How about the bonus question? Okay. What's a different? Eli? What's a different way to describe? I said you write it down first.
-2 radical 2 25.
Okay. Eli wrote down -2 radical 2, 225 degrees. And why does it work like that?
Because you rotate all the way to the third quadrant backwards.
Okay, so we could rotate to the third quadrant and then walk backwards. Okay. Okay. What you just worked with is polar coordinates. Okay? And it's all about trigonometry. Okay? Let's go through the difference here. And I don't think you need to write this down. Okay, this is what you did in the very beginning. Cartesian coordinates, the XY axis. Okay, we worked on a grid system. Okay? Not always is a grid system the best option. So we have polar coordinates. Okay, now you have in your handout there that our coordinates are r comma theta, but if you want to write down in your notes somewhere, that r is representing the distance from the origin, okay? We call it the pole, hence polar coordinates. Okay, the ordinate is called the pole. And then theta is that directed angle from the polar axis, or that positive x-axis. Okay, so we're basically taking our trig stuff from chapter 4, and we're using it to describe coordinates in a different way. Now, these coordinates are listed as r comma theta, but I like to think of rotating the angle and then walking out the distance. Okay, to me that makes more sense than walking out the distance and then trying to rotate, right? So they're going to be listed in alphabetical order, r comma theta. Okay. Just emphasizing the T and the theta, okay? But I'm always going to think of the theta first, okay, as far as plotting the point, okay? Now, you saw my cheesy polar bear at the on the first slide. And it was on something like this, okay? I wouldn't necessarily draw that one, okay? That one is pretty intricate, so give me a moment and I'll show you what you will see. But basically, on a polar graph, you're going to have the polar axis is here. So you're going to have horizontal and vertical axes. This is called the pole, and these concentric circles, those are your grid marks, essentially, and then you have your angle marks, okay? I will tell you that on your tests and quizzes, you know, that's beautiful. But you will get something that looks like that, okay? I'm trying to go really fast. But you're going to get more of the, you're going to get the unit circle values. So you're going to have the 30, 45, and 60 in each quadrant, okay? I'm also going to tell you that we're going to use radian measurements, okay? Some of you, I know we kind of got used to degrees in chapter 6, but we are going to use radian measurements, okay? So let's talk about really graphing on the polar on the polar graph here, okay? Let me get this down. Okay. So I wanted to graph a couple of these here. Okay, we're going to do this first, okay? And then we'll graph. So let's talk about all of the mathematics behind what you just did, okay? If we have an XY coordinate, how did you figure out what theta was? What did you use? Okay, we know that this is a triangle with x and y as the sides. So we know that the tangent of theta is y over x. Okay. R represents the directed distance. Essentially, this right here. Okay, this red right here. What trigonometric concepts can help us calculate R if we know x and y? The Pythagorean theorem. Okay, ladies and gentlemen, if you have an XY coordinate and you want to know what it is in polar form, these are the two things you would need to do. Okay, that's essentially what you did outside on the sidewalk. Okay, now let's talk about going backwards. let's talk about going backwards. If I give you a coordinate, r, comma, theta. How do I figure out what x is? Okay, we know that the cosine of theta is adjacent over hypotenuse. So x is going to be r times the cosine of theta. Look familiar? That doesn't like bring you back to chapter 6 a little bit? Not even a little bit? Thank you for your honesty, Caleb. If we wanted to figure out y, what is going to help us if we know r and theta? Sine. We know that the sine of theta would be opposite over hypotenuse. So y is r times the sine of theta. Okay? These 4 conversions are what you need for this entire section. Okay? If you can understand where these come from, you can convert polar coordinates to Cartesian, Cartesian to polar, and we're even going to look at the difference in their equations. Okay? So let's go ahead and practice graphing. Okay. So I'll give you a moment to A, write down the coordinates, and B, just draw that simple polar plane that you see up there.
Didn't you say we could answer?
Yeah, Richard, go. You're the closest.
Gosh darn
It's
it. Yes? Sure. Chad must have gotten me to see. Okay. So if we are going to plot 3, negative 3/4, let's first rotate negative 3 pi over 4. Thank you. I was going to explain their homework. Okay. So negative 3 pi over 4, which quadrant is that in? Okay, negative 3 pi over 4, we rotate this way to here, right? So here's negative 3 pi over 4, and then our R value is 3, so we would move forward 1, 2, 3. There it is. Okay. There are 4 ways to describe a coordinate. Staying between negative 2 pi and positive 2 pi. Stay within one rotation of the unit circle. I'm going to give you 1 minute to brainstorm at your pod up to 3 different ways to describe that coordinate besides 3 comma negative 3 pi over 4. Caleb, what cost do you need to calculate your 4?
every 225. using it, okay? I don't want to use it.
I guess we could do the finger.
Remember Eli's description of walking a different direction?
What's you need your calculator?
Well,
That's fine.
three times the right rotate.
Is it 5?
But negative 3 times 4, we're rotating that same amount, but in the opposite way. So here we go backwards.
I'm Caleb.
That's why I said, well, they do it right. That's what he's
You realize how we're all, you realize how we're all so you're not.
Okay, somebody in top one. Give me one.
Pi over 4. Or no, sorry. But not that one. Yeah, pi over 4 and negative.
Okay, because we can rotate the pi over 4 and then walk backwards 3. Excellent. Pi 2, do you have a different one for us? Okay, we can rotate to 5 pi over 4 and then walk forward 3. Very good. The last one's probably the least obvious. Chris? We can rotate to negative 7 pi over 4 and then walk backwards 3.
No, I saw
Okay? So there are 4 different ways to describe a coordinate staying within one rotation of the unit circle. Positive r positive theta, negative r positive theta, positive r negative theta, negative r negative theta. Okay? I have a stamp. Okay? So my intention was to print off little graphs for you so you can just take them in your notes and homework. But I had a meeting this morning that ran long. So I have a stamp. I'm going to come stamp in your homework when we get to the end of the class period, okay? Sound good? So then you don't have to draw that every time. Yeah. It really is going to look something more like that. With flat lines. Okay, so now we are going to practice converting. We're going to practice converting coordinates, and then we're going to practice converting equations. So the first coordinate we are going to convert is negative 1, 1. Okay. Okay, you don't have to graph it, but I'd like to give you a visual here. Negative 1, 1 is in the second quadrant. Why is that important to think about? If we think about, well, first of all, we know that r squared is x squared plus y squared, right? So if we want r, it would be radical 2. Some of you don't even have to do the math. You just are going to know that because of how much we have worked with right triangles, okay? But why is it important for us to know that it's in the second quadrant? When we go to do the tangent of theta equals y over x, there are a few different places where the tangent of theta is negative 1. BTW, no calculators on this. Okay? The tangent is negative 1, and we are in the second quadrant. We have one option. What's our option, Nick? 100, wait, do you want in radians? 3 pi over 4. Okay? So you would tell me that this is the coordinate, radical 2, 3 pi over 4. Okay? Now, technically, yes, you could get crazy and you could say negative radical 2 5 pi over 4. But I would prefer, right, did I say that right? No, 7 pi over 4, excuse me. You could say negative radical 2 7 pi over 4. But if we're doing conversions, I would really appreciate if you stuck with positive r, positive theta. Okay. This one, you have to think about to make sure you get the right angle. If you have a polar coordinate and we're getting back to Cartesian, really not a whole lot to think about. Pretty straightforward. Yes. Yes, it is. Okay. So we know that this is r comma theta. We know that x is r cosine theta, and we know that y is r sine theta. Okay. So now, again, just like last chapter, you gotta know our unit circle. Okay? The cosine of pi over 6. Arissa, what is that? Okay, so our x-coordinate is 3/2. Awesome. Y is r sine theta. Grace W, what's the sine of pi over 6? 1/2. So our coordinate in Cartesian form would be 3/2 radical 3/2. Okay. Now we just have some fun. Coordinates. Awesome. Now we're going to convert equations. Okay? The reason we do this is, first of all, we can understand the relationship. But there are also times where polar equations are way better to work with than Cartesian equations. Okay? And we're going to get to spend 3 days, Tuesday, Wednesday, Thursday, graphing in polar coordinates, like equations in polar form. And it's going to be pretty neat. Okay? While I'm thinking about it, bring your calculator tomorrow. Okay? So first of all, r equals 2. This is an equation. R equals 2. If I'm in polar form, r equals 2. What does that mean? What does that look like? Why? R is 2. R is always 2. Yeah, that's describing a circle because our radius is always 2. Okay? Now, do we have an equation that relates r to x and y? What is it? X squared plus y squared equals r squared. Right? So, in this case, we know that r squared is 4. And we know that r squared could also be written as x squared plus y squared. Hey, guess what that is? A circle with center 0, 0, radius 2. Okay. Second one. This is an equation. Think about what it means. Anyone have an idea of what that would look like? Why is it a line? Theta is always pi over 3. Okay, we have a line. Okay, that's exactly right. This is a line at an angle of pi over 3. Theta is always pi over 3. It has no effect on what r actually is. Okay, now that's an equation that we need to get in terms of x and y. Is there an equation, one of the 4 that we wrote down on like that second or third slide, is there an equation that has a theta and relates it to an x and a y? Tangent. We know that the tangent of theta equals y over x. Well, we know that theta is pi over 3. So we know the tangent of pi over 3 equals y over x. And the tangent of pi over 3 is radical 3. So, ladies and gentlemen, if we solve for y here, this is a line that goes through the origin and has slope of radical 3. How do you feel about graphing a slope of radical 3? My group of sophomores giggles. I more 2 words together. I'm sorry. Graphing a slope of radical 3. Does that sound enjoyable to you? So theta equals pi over 3. Boom. That's pretty easy to draw. Okay? Now, in our last 7 minutes, we are going to go the other way. We're going to take equations with x and y, and we're going to get them into r and theta. Okay, we're going to get them into polar form. Okay? Now, when you do this, I still want you to use the substitution formulas like we've been talking about, but I want you to make sure that you attempt to solve for r. If, like in our last example, we didn't have an r in the equation, if r goes away, then solve for theta. My advice to you when you do your homework, I would write those 4 conversion formulas at the top of your paper. I'll come back. These 4, 1, 2, 3, 4. Write those at the top of your paper. Anything you do, you need them. Okay? Conversion of coordinates, conversion of equations. So x squared plus y squared equals 16. We need to figure out a way to get rid of the x squared plus y squared. Thoughts? Chris has participated a lot more than other people, so I'm going to give someone else.
X squared plus y squared equals r squared.
Okay, we have the equation x squared plus y squared equals r squared. So we know r squared is 16. I'm asking you to solve for r, so I would expect to see r equals 4. Yes.
Yeah.
You can just say r equals 4 because that can make a complete circle with radius 4. Okay? This is one of the times where you don't have to put the plus or minus. Okay? Because it's describing the same thing.
I think we should add something.
Okay. Example number 2. X equals 3. That's a vertical line, yes. But how are we going to convert it to be in terms of r and theta? Okay? So if you don't have something nice like x squared plus y squared, look at your other formulas. What do we know about x? It equals r cosine theta. And I'm asking you to solve for r. So we would divide cosine to the other side. And when we divide by cosine, 3 over cosine is the same as 3 secant. Okay? So that's what you're going to see. I'm going to go through one more example and then I'll come around and stamp your homework. Yes? If we are solving an equation and it could be 0, we would not be able to divide by it. But here we're just rearranging a formula. And so we just can't plug anything in that will make the cosine 0. Does that make sense? So we probably have we have some undefined things happening. Okay. All right. This is the last one we're going to do right here. Write that one down. 3x plus 5y minus 2 equals 0. Okay? I'll be very straightforward with you. If you do not know where to go in a conversion, plug r cosine theta in for x. Plug r sine theta in for y. From there, just rearrange. Okay? Now I'm going to zoom through this so I can stamp your guys' homework if you want it. But do you notice how these first 2 terms both have an r and we need to solve for r? So we can factor an r out here. Add the 2 over. And then to get r by itself, we are going to divide by that ugly factor. If you want a stamp, have your homework open, I'll come stamp you. Stamp. Okay, this is a stamp to plot point. You want a stamp? Raise your hand. Stamp. You want a stamp? Otherwise, you'll just have to draw it in yourself. Who else wants a stamp?
Whoa.
Where is it?
There you go.
No, because I wasn't.
Have patience as you're doing the conversions, okay? Be creative. Everyone is different. Okay, every problem is different. We'll go through problems tomorrow, but try them all. Be creative. Oh, yeah. Okay, let me stop my recording.
I bet you.